In this video we are going to look at how the player is able to modify the terrain. To generate the terrain we use the Marching Cubes algorithm. There's a lot of information on the internet about how the algorithm works. One example is the video found here on Sebastian Larg's YouTube channel. I recommend you watch it through if you want to get a better understanding of how Marching Cubes works. For our own purposes, we have the terrain divided up into chunks, with each chunk having a width and a depth of 16 meters and a height of 100 meters. This is filled with 3D noise, and the Marching Cubes function steps through each cube one at a time, and if all the corners of the cube are negative, it assumes them to be underground, and if all are positive, it assumes them to be above ground. In any cubes that have both positive and negative value corners, it assumes that the terrain goes through that cube, and the algorithm works out the triangles needed to be placed inside that cube to draw that single piece of terrain surface within it. Once it has stepped through each of the cubes in a chunk, then the terrain area for that chunk is complete, and when all the chunks are placed in the playing area, the whole terrain is generated. Once the terrain has been generated, to modify it, it is simply a case of altering the corner values of a cube that has the terrain running through it. Giving all of the cube's corners a positive value will make it be considered as above the terrain, therefore giving the impression that the terrain has been dug out, and conversely, giving all of the cube's corners a negative value will make it be considered as below ground, giving the impression that the terrain has been filled in. Once the cube values have been altered, then we simply run the Marching Cubes function for the altered chunk again, and the updated terrain is generated. If we run the game now, we can see this in action. Now we're in the game, we can see left mouse button removes the terrain and the right mouse button fills it in again, which is nice and straightforward. However, there is a problem, and that's when you have two neighbouring chunks. So if we go down here, we can see that we've got the chunk here with the green grass on and the chunk here with the desert. So if I was to click on the grass here, both the desert and the grass have to alter the sides to match, otherwise if the desert hadn't moved, then we would have had a tear in the terrain. To stop any tearing, if the modified cube is at the edge of the chunk, then once the chunk has been modified, we look at the value of each of its edge points and match the neighbouring chunk's edge points to the same values. Then we run the Marching Cubes function on the neighbouring chunk as well to ensure the terrain is correctly joined together, a method I call seaming. You'll see comments in the code where seaming is taking place. To help us visualise this further, if we click on Dev Mode Manager, you can see we have two options to help us: show terrain hit position and show hit cube. If we check the first one, then we will get a red highlight around the terrain triangle that we have hit with our raycast. We can alter the number of seconds it is displayed here. At the moment it's on 10, so we'll leave that. So now if we go back into the game and we click, we'll get a red triangle outlining the area of the terrain we've clicked on. We'll do it over here, we get another one. Now you must be aware that to see this in game mode, you have to have this gizmos checked. If I unclick it and then try again, we don't see it. So that's something to be very aware of when you're doing this. There we are, it's back again. Now if I do show hit cube and check that, we will get a blue square around the cube that we've hit. So if we hit now, you can see the area of the terrain, and it's also worked out the cube that it's altered all the points for. You will also notice that the grass is removed from the area that is altered. In fact, all scenery items are removed from the altered terrain to prevent items being left floating in mid-air if the terrain is moved from underneath them. Now the grass controller script on the grass prefab handles this itself, but other scenery items rely on having a collider attached. Now larger items, trees and rocks and so on, will already have a collider to prevent the player from walking through them, but smaller items such as bushes and stones that you may want the character to pass through will also need a collider. But in these cases the collider will be set to a trigger so the player can still pass through, but the collider is detected when checking if any scenery objects are within the radius of the altered terrain. That's it for this video. Check out the website for other MC Train videos and documentation.